Hello, this is our first lesson on the introduction to functions. And in this lesson, we're going to look at whether data represented as tables, ordered pairs, mappings, or graphs are functions or whether or not they are non-functions. And this first video is going to look at data represented in tables and ordered pairs. So we're going to look at tables first. I've got two tables already showing here. One's labeled as a function and one's labeled as a non-function. And I know that we're used to seeing tables in X and Y, and even though they've got different letters, we can think of them as X and Y. They're still the same thing. The X values are always on your left, the Y values are always on the right. And when we talk about a function, what we are concerned about is the X values. It's the X values that control it. Those are the independent values. So I'm going to highlight these. And it's the same on the non-function. And if we try to look at, well, what's the difference in these X values here? On this set, the only difference, because it's the Y values we don't care about, it's the X values that are in control, is that I notice that on the set that's a non-function, I've got a set of repeating 2's. So I have what we call X values that are repeating. So I'm going to write that in there. It doesn't have to be all the X values, but as long as you have one. And then on the other side, I notice that I have no X values repeat. So that seems to be kind of interesting. Let's see if that continues. So if I go to my next set, again, it doesn't matter what letters they use. They can use X and Y or any other letters that they want. I'm just going to check this. And again, it's only the X values that matter, so that's the only ones that we're looking at. And as I look at the ones on the left that are in the function column, I notice that none of those repeat. Doesn't matter what the Y column does, none of those repeat. But on the other one, I've got a set of repeaters here with the -3's, and then I've got another set of repeaters here with the -2's. And as long as anything repeats in the X column, okay, that looks like that's something that is happening both times, and over here, no X values repeat. Let's look at the last set and see if that holds true. Okay, and we're going to remember X and Y, X and Y, and the only thing that matters is our X. So if I look at X, once again, none of those repeat. If I look over here, every single one of these is a repeater. So once again, getting the X values are repeating, and that's if it is not a function. But when the X values do not repeat, that's when we have a function. So if we sort of look at what happened every single time over here in my function column, in order for it to stay a function, none of the X values repeated. In the non-function column, we always had a repeat. So that's sort of what we're looking for, the fact that the X values do not repeat. So let's go back and see if that holds true. That was for tables for ordered pairs. Okay, so here's my set of ordered pairs. I've got a function and a non-function. I'm just going to go ahead and remind myself that every time I write a set, it's the X number first and then the Y number second. I'm going to do that for both. And now I'm going to highlight my X values, because remember, it's the X values that matter. Okay, and if I look at these, I don't have any ones that repeated. I'm going to go over here to my X values. Oh yes, I definitely have some repeaters. I've got -6 repeating there and -5 repeating there. So I've got X values repeat. And that's what makes it not a function. Whereas over here I have no x values repeat, and that's what makes it a function. So in order to have a function in your tables or in your ordered pairs, none of the x values can repeat. If even one of them repeats, then that set of data is not a function.